since every time you consider limit means we are considering delta neighborhood and limit is approaching from all the sides. So it's important that that delta neighborhood should be contained in the domain, not it. So you understand this open domain, we also need it in complex plane, open domain and connected domain. And connected domain, if you have in R, so it's a region, if you find any 2 point, you should be able to join it by a finite number of line segments, and that path should be contained in the domain. Okay. So like here you have 1 point and here. So here, let me consider something like, so you have a point here, 2 points. So you should be able to find a path which is from, okay, this one. Now you see this, there are points which are not inside the domain. These points, okay. This is not, right? So here you see, you can get a path from this one, like this. Okay. So the path should consist of finite number of straight lines, and this path should lie entirely in the domain D. Then it will be a connected domain. Like suppose you will go, you are going, this one is known as the annulus. Okay. The area bounded by two concentric circles. It's known as annulus. Okay. So now you see, if you find 2 points here, this one and here this one. So if you consider a path like this, there are points which are outside domain, but we can have multiple paths. Okay, it's not exactly one path. You have multiple paths where which are outside the domain. So you see. So here this way you can consider. Okay, so this path is lying inside the domain. Okay, we are able to find a path where the path consists of the finite number of line segments lies inside the domain. So this is also a connected domain. Okay. Only thing, if you are getting a domain like this one. Okay. So this is D1 and this is D2. That means there are two parts completely disjoint. Okay, then it's possible that it will be a disconnected one. Suppose you have a point here in P1 and P2. Then for this part, okay, there are no path. You find out all possible paths. Some portion of the path will lie outside the domain. Okay, this T you can say T1 and T2. Union between this. Okay, there will be infinite path, but all paths, there are some portion of the path which are lying outside the domain. Okay. They are not in the domain. And D is D1 union D2. Okay. So now this will be not connected, or you can say disconnected. This is not connected. Okay. But if you consider 2 points in D1, there you see this will happen. Only if you consider 1 point in D2 and the other one in D1, then if you connect, then the path, some portion of the path. Some domain D in R2 if there exists a real finite number positive number n. Such that the absolute value of the function is less than equals to n. Now xy belongs to y. So now we will come to the limit concept. Okay. So here limit. So we will see how we are extending this limit concept from one dimension to two dimensions. So when you say limit exists for a function at a given point, to remember, okay. So we have this one, the real line, one dimensional case. We will say limit x approaching to x naught, f of x equals to L. So when we say limit exists, what do you remember for that? So you have a here, correspondingly we have f of x naught. So how do you say limit exists? What is the, how you understand that limit exists? Anyone?
Left hand limit is equal to right hand limit.
So left hand limit and right hand limit, they are equal. Okay, you see. So that means okay, and where it, so limit exists if left hand limit at and the right hand limit at x naught is same. Okay. So now here you see in R2 what happens. See, we have two things. Okay, x y. If you are saying at x naught y naught, it will approach x naught y naught. So f of x naught y naught L. Now what you understand here? Here we have the entire R2. The domain will be either R2 or subset of R2. Suppose we have a point in the domain. We will say this one is the point P x naught y naught. Okay. So now you can see what you can say here. So limit here, it's only one line. So we have only possibilities left hand limit and right hand limit. You see here. And it's the delta neighborhood. This one is x naught minus delta. This is x naught plus delta. And what is the neighborhood here in R2? It's a circular disk. Right? So here this is for right hand limit and left hand limit. Now you see limit can approach to x naught y naught from this way also. From this one also. Infinite number of ways are there. So in R2, limit concept is much more stronger than what we did in real number case. And you see, not only the straight line cases, you can also have the curvilinear paths. Okay. And it's not that the path can be like this, any curve, what it is way. So here there are many paths, infinite paths. The examples what I did, limit. When I'm saying xy approaches to x naught, y naught means in the delta neighborhood of x naught, y naught, limit is approaching to L. So there are infinite paths. In the real line, only left hand limit and right hand limit, they are equal. But here you have infinite paths. And in each path, limit exists means it's unique, the value is unique, and the limiting value must be unique, same in all paths. Okay. So few, you can say here, if you look at the path for the straight line paths, you can consider y equals to mx. For some curvilinear paths, you can consider y equals to mx square, y equals to mx cube. So these are some examples you can see. Okay. So this one. And it's not that you can also go for the high. Okay. So if here also we have the same definition, but we are talking about two independent variables. Okay. So let me write for two independent variables. Same we can extend for the 3 variable and 4 variable cases. So if for a given real number epsilon greater than 0, if you remember for limit we have epsilon delta definition. Okay, the same we will try here. Okay. See how we are extending this one. Okay. So it's kind of xy approaches to x naught y naught. in the delta neighborhood of x naught, y naught. So there are many ways. So now let me write this one. So if for a given real number epsilon greater than 0, we can find a real number delta greater than 0, such that for every point xy, so f of x naught, y naught, limit is approaching to L means f of xy minus L less than epsilon. Whenever x minus x naught square plus y minus y naught square is less than delta. And this delta is dependent on epsilon. Both epsilon and delta they are. So here also we consider the positive value. Okay. Epsilon, delta, they are small positive in real numbers, and delta is dependent on epsilon. And there is one, the same definitions we are extending to here. If limit exists, then it is unique. Okay. If limit exists, then it is unique. In all paths, you will have the same limiting value. So if limit exists, it is unique. Now let's see, using this epsilon, delta epsilon method, we will find out limit. So using delta epsilon approach, find limit. So let's take the first one, first question. Limit xy approaching to 2, 1, 3x plus 4y equals to 10. It's a very simple one, but we will see with respect to the delta epsilon approach. Okay, what's happening here? So that means we will try this one. Okay, we will try to show f of xy minus L less than epsilon whenever this happens. So we start with f of xy. It's well defined, you can see. 3x plus 4y. Okay. So we'll start, it's defined at 2, 1. And we know the functional value here is 10. Okay. So let's try with this one, f of xy. Limit is already given. We will show that it exists. So minus 10 less than epsilon. Okay. So we will try to simplify this one. Okay. We will show this is less than epsilon, and we will be from this epsilon. Okay. This is actually less than epsilon, but we will try to find out some value of epsilon so that delta value we can find. Like you did in the one dimension case. Okay. So this is 3x plus 4y. Okay. So here you see one thing you can say here. x minus x naught is 2. Okay, what we will try to show that this one is y minus 1 square. So this should be less than delta. Okay, we will try to find out this one, and this delta should be less than 10. So we will write down this one 3x minus 2. So this will be minus 6. So how much we are left? 4y minus 1. So here it is minus 6 minus 4. We are getting this as 10. Okay. So now this is what we have written. Okay. Now it should be less than 3 mod x minus 2 plus 4 y minus 1. And it's less than 3 delta plus 4 delta. Okay. So what we are getting is, because x minus 2 is less than, okay, this x minus 2. We know that this less than delta because this happens. So here we can substitute this one. This 7 delta we can consider as epsilon. Okay. So delta must be, delta we can consider as epsilon by 7. So this delta value we are getting from 7. So here we can see, we can write it f of xy minus 10 when you consider this is epsilon, whenever this x minus 2 square plus y minus 1 square is less than this delta. Okay, and you can say this delta is epsilon by 7. And if you consider a very small number epsilon, we will say if xy minus 10 is less than suppose 0.001. Then you can consider here 0.000. One more 0 you can add 1. So that will be epsilon by 10. It will be less than 1. Okay. So this is how you can solve. Let's try for one more. Limit xy approaching to 1 1 x square plus 2y equals to 3.
मेरा स्पीकर ले रखा है अपने साइड पे। ये मेरा
Yeah.
फोन का स्पीकर है फोन का।
What are you saying?
कुछ नहीं बोल सकती। कौन सा सुनी?
What happened?
Ma'am, there is a lot of network issue. Yes, ma'am.
Who is recording? I want to know. Anyone who is having good network?
Everyone is having good.
No. Why I'm saying he or she can record this one. That's why I'm asking if any of you is having good network, proper network.
Actually, from hostel Wi-Fi, everybody is doing network.
Okay.
Ma'am, Jio network. No.
Okay. Okay, you see then this one I'm doing this problem, you just see. Okay, then we will close this one. Okay. So I'm not going to do it very fast. Okay. So here you consider this f of xy equals to x square plus 2y. Okay. So like we will start with f of xy minus a. So this will be x square plus 2y minus 3. Because at 1 1 it's well defined. So we will try to write it in this form. So x minus 1 square, then you will have minus 2x minus 1. So here plus 1, so here you will be getting 2x. Minus 2x is there, so we will add here plus 2x minus 2. Okay, so plus 2x minus 2, and here for y minus 3 we will write, so here we will make it 2 into y minus 1.
Ma'am, -4.
Minus 2 and minus 2.
Ah,
So
okay,
what
okay.
is it okay now? You can also make it x minus 1. So here this is the form. So here we will try this one. Okay, x minus 1 less than delta, and we will try to write it in this form so that at the end we can get it. So here x minus 1 square plus 2 into x minus 1 plus 2 into y minus 1. Okay, now x minus 1 is less than delta. So directly you can put it x minus 1 delta square plus 2 delta plus 2 delta. This delta square, delta is very small, so delta square is also less than delta. Okay. So here you can make it 5 delta. So it is up to you. You can put it, or you can make it 5 delta also. Delta plus 4 delta, that is 5 delta, and this will be your epsilon. Okay. So here f of xy minus 3 less than epsilon whenever x minus x naught square. So x naught is, you can put it here, it is 1, 1. So plus y minus y naught square less than delta. And this delta here, you can see epsilon by 5. Okay. So if you go for epsilon by 6, that will also work. Epsilon by 7 also work. Okay, this is how you can try.
Ma'am, why delta square becomes delta? It becomes
Hey,
0 now. Small.
no, what I'm saying, I'm just trying to write it in terms of delta. So epsilon, you can find it. Okay, delta is very small. Yes, very small positive number. Okay, so delta square is less than delta. Okay, that we have used here. Just to make it a little simplified version, if you want, you can also keep it delta square also. Just we can put it as epsilon by 5. That's why I have made it delta square less than delta. So here one more you can try with this delta epsilon approach. So that xy approaching to 0, 0. Zero. You saw this one, okay. You can go for substitution also. Okay, one best thing is you can go for the polar form. Whenever in the denominator you have x square plus y square, it will be easier. You can substitute this one. Okay, so here this f of xy, but you can also substitute if you want. So in a simple manner also you can say xy, you can say it's less than half of x square plus y square, that also you can do. So what will happen? Is it working if you put r cos theta? So here it is 0, so we will try to show it's less than epsilon. Okay, so here we have xy. Okay, minus 0. Or you can put it minus 0, it's same. So now you see xy by x square plus y square. So here what you can put here, r cos theta, if you put r cos, this will be 1 and r will be in the denominator. So 1 by r will come out. And here in the numerator, r square.
R square cos theta sin theta.
Okay, now you
R
know
by
that,
2 sine 2 theta.
yeah, r by 2. Or you can keep it, okay. If you want, you can write r by 2 sine theta, or this one, you see. You can use the fact that cos theta is bounded by 1 sine theta. This is also bounded by 1. So here one r will get cancelled. We have 1 by r. R is a positive number, so we don't have to put magnitude. Now, if you want, you can write it like this, or you can also write that 2 theta form. This is less than 1, we can make it 1 by r. Okay. So once we have in 1,
Ma'am,
yeah, yes,
ma'am, R only, ma'am. R,
Are
1
giving
by R,
number
not R.
yes, sorry, it's r. So r, okay. So if you want, you can consider r as your epsilon. Okay, it's up to you. Okay. Now, what we need is x square plus y square less than x square plus y square. Okay. Because it's actually x minus 0 square plus y minus 0 square. Okay, this is x square plus y square, and x square plus y square is r square. This is r. Okay, so it's coming at r less than this much. So we should have this form of this one. Okay, so r we can substitute back x square plus y square this way. Okay, now x minus 0, if you remember, this is less than delta y, since they are approaching to 0. So this one, here and there. Okay. So here x square plus y square we are getting. So x square is less than delta, y less than delta. So you can say delta square plus this will be root 2 delta. Okay. So you should start from xy minus 0, and you should be able to let it to the form x minus x naught square, y minus y naught square. Here x naught, y naught are origin. So this is what this one is. So you can say here f of xy minus 0 is less than epsilon whenever here it is x square plus y square less than, this is a delta, and this delta you can consider as equals to epsilon by root. Okay, you can consider root 2 delta as epsilon, and delta is as epsilon by root 2. Okay, this delta will be dependent on epsilon. Okay, so now this is what the epsilon, now you understand what is epsilon delta form. So now we will show that we will show whether limit exists or not. Okay, for this particular case, find the limit. So you can use epsilon delta method, or you can try it the other way. Xy approaches to 0, 0, and xy by x square plus y square. Okay. See, you can see in the numerator we have xy, and here x square, and here limit can approach to the point among different paths. So let's say, you see, for all paths you should be getting the same value. We can put y equals to mx. Then here only x approaches to 0 is enough. X and x square plus m square x square. So what we are left with, m by 1 plus m square. Now what you say, limit exists or does not exist? What you can say?
exists as a
No, it does not exist. See, I have written y equals to mx means. What are the paths, you think? So what are the paths here? Y equals to mx means we are considering all the paths. Y equals to x, 2x, 3x. So if you consider different value of n, you will be having different limiting values. Okay. So this is So the limiting value depends on m. M is a very general value. Okay, it can be 1, 2, 3, half, 0.2, 0.3. Okay, so for different values of m, that means different values of m means along different paths. We get different limiting values. We have different limiting values. M can be 1, 2, 3. Okay. So limit should be unique, whatever be the path. Normally when you have to show limit does not exist, you should try. You can also try this mx square, but you see, if you consider mx, there will be some cancellation and you are getting this one. So let me do one more example and you can see it from there. Okay, so x plus root y and it's x square plus y. So you have to find this limit, okay? Find the limit. So see, if you put y equals to mx, what happens here? Root x will be there. Okay. Even if you go for the root x, you are still left with x in the denominator. Our purposes, if you can simply this y term and x term, you should have m term, then you can show does not exist. For existence, you try that epsilon delta method or directly some cancellation. So here you see, if you put y equals to mx square, what happens here? This will be x. Here mx square. So x you can take out. Okay. So let's try what the limit is coming. We will see. X plus mx square. X square plus mx square. So here what will be the limit? So what you can say? 1 plus root m and divided by x into 1 plus m. So what you say? Limit exists or not?
Infinity exist.
It will exist. X is there.
Infinity.
So if infinity limit exists, what I said? If you have infinity, see, what we say limit exists means limit is unique and it is finite. So this means limit is finite and unique. Where you arrive if you go for the infinity? So if you say limit exists means it's finite and unique. So limit does not exist. Alright. So you do one more example. Find this limit. I get plus. That will be easier. So what do you think? Now if you make it plus, it won't. There won't be any cancellation. So are you done? So I already did same type of limits. See here you have x power 6. So if you consider the path y equals to which path you will consider? By looking at this, you can say here, okay, if you consider y equals to mx cube, so here it will be x approaching to 0. M square x6. So what you are left with is m by 1 plus m square. Again, this limiting value is dependent on n, dependent on the path. It depends on m means depends on m values. So for different paths, you will have the different limiting values. So limit does not exist. Normally, these paths you should consider whenever you have to show limit does not exist. Okay. So one last one you do, and we will do limit. Yeah. Tan inverse y by x. So where here the question is x, y approaching to 0, 1. So it's a well-defined thing. So what you will say about limit?
We can substitute y is equal to mx.
Yeah.
We can substitute y is equal to mx. So tan inverse m.
Tan inverse m is?
No, ma'am, we don't substitute
Y
like
is
that.
equal to mx.
So whether limit is existing or not, if you put y equals to mx.
Given to m, so it will not exist.
Tan inverse, if you put y equals to mx, then it will be. Can you put y equals to mx?
No, ma'am, we can't put m y equal to mx because 0, comma 1 is the point. No?
Yes, 0, 1 is the point. You can't put y equals to mx.
Yes, ma'am.
When the x is approaching to 0, y is approaching to 1. Since limiting value, you see, directly put the values, what you are getting. Tan inverse.
Tan inverse infinity.
So what you are getting? Tan inverse infinity. For which values you are getting? What is the value? See, again you see when x is approaching to 0, y is approaching to 1, we have infinite paths again. Okay. So not only infinity, you can have both paths. Okay, minimum path even you consider you will be getting at least plus and minus infinity. Okay, so there are many paths. So let's make it plus and minus infinity. So what you will be getting? What is the value?
Pi by 2 plus or minus pi by 2.
Plus and minus pi by 2. So what do you think limit exists? Limit
Not
exists.
unique, no, ma'am. Ma'am, not
Yes.
unique, no. Two values.
So limit does not exist.
Yes, ma'am.
Okay, fine. So we will do the continuity next class. Okay, continuity and the partial derivatives also.
Ma'am, will you please take the classes in offline mode because there is a net issue.
I asked that. Okay. Then we will let me see, or I will. For after 1-2 days, I will think about it. Okay, tomorrow I will tell you what to do. Whether I will go for your class or not. Okay.
Ma'am.
Okay. Anyone who recorded? No. Okay, fine.
Thank you, ma'am.
Thank you, ma'am.